Hi, welcome to Chem 2005. Today we will focus in diazines, which compounds are and how to synthesize some of them. Okay, basically diazines are 6-member rings that contains 2 heteroatoms, has to be 2 nitrogens, and we have 3 different structures. When we have 1, 2 nitrogens, the nitrogens are contiguous, it's a pyrazine. If we have the 1, 3, okay, it's pyrimidine, and if we have 1, 4, it's pyrazine. These compounds are quite important in medicinal chemistry, and the most important is the pyrimidine. That is what we will focus our attention. Okay? One of the things that we need to consider is the reactivity. All are aromatics, you can see, all have 6 electrons, all the atoms are sp2, is planar, and is cyclic. That means all are aromatics. One of the characteristics is that the pair of electrons of the nitrogens are in a sp2 orbital. That means that will be extremely basic, because we have 2 nitrogens that are basic. If we check how electron poor or electron rich are, these compounds are very electron poor. Why? Because they contain 2 different heteroatoms. That means we have 6 electrons for 6 atoms, but we have 2 atoms that are more electronegative than not the carbon. That means that these 2 atoms, that's 2 nitrogens, will attract more the electronic density to them, and will allow that all these carbons will be very electron poor. That means that basically the electrophilic aromatic substitution will not work. Okay? Only will work if we have activating group. For example, if we have this compound, where we have 2 activating groups, these 2 OH, if we do, for example, annihilation, what will happen is that we will have the negation in this position because it's ortho to this group and para to this group. Okay? What we will have is the negation here. But this is only working, and it's not working very well because we have 2 activating groups. If we don't have any activating group, simply the reaction will not work. And just the opposite, when we are doing the nucleophilic aromatic substitution, will work very well. Especially when we have this compound this, for example, will work very, very well. Okay, well, so will be very active in the nucleophilic aromatic substitution. How we can synthesize pyrimidines? Okay, if we check a pyrimidine, okay, the first thing that we can see is that I will put some substituents. Okay, the first thing that we can see is that this is an enamine. Okay, that means that we can break this bond, and this can come from ketone or an aldehyde. Plus this. Okay, and we can do exactly the same. Here is an imine, that means that we can break this, and this will come from one free decarbonyl compound plus an imidine. Okay, if we do a forward synthesis, okay, here what will happen, normally this is in acid media. We can do pyrimidines in basic media, but then we need a different starting compound, checking the notes. Okay, the first thing if we are in acid media is to protonate one of the carbonyls. We are making this carbon more electrophilic, and then what will happen is that the amine will attack here, and we will form the imine. Okay, when we have the imine, what we can do is isomerize imine enamine, and then isomerize this compound. Basically what I do is put the double bond here. I am doing like a tautomerization in this compound. Okay. Okay, I put this hydrogen in this nitrogen and the double bond here. And when I have this, basically the carbonyl takes a proton, is protonated, and then the amino group attacks here, forming the imine, and what I get is pyrimidine. Okay, this is the most common way to synthesize it. Okay, there are other ways also in basic media. Please check the notes. I will say that are less important than not this. And the last thing that I want to say is that this type of compound that I draw here could be basically, this is equal to, for example, ureas or imidines, thioureas, etc. Okay. And that's all. This is the mechanism for the acid catalyzed synthesis of pyrimidines. That is probably the most important synthesis of pyrimidines. And please check the notes about the basic. And that's all. That's all for diazines. And then to finish this course, I will talk about the basicity. Okay, it's something that I talk during each lecture, but I will summarize when a compound is acidic or not when we have heteroaromatics. Okay, basically we have two compounds, two basic compounds that are pyrrole and pyridine. All the other compounds will be combinations of pyrrole and pyridine with some other things. What we have to check to know if one heteroaromatic compound, one nitric acid heteroaromatic compound is aromatic or not. Well, it's basic or not. Well, what we need to check is the double bond, the pair of electrons of the nitrogen. And we have to localize this pair of electrons. In this case, this pair of electrons are part of the p system. Okay, we have 2, 4, and this pair of electrons must be in the pz orbital. If they are in the pz orbital, means that they are not accessible. That means that this compound will not be basic. In the case of pyridine, the pair of electrons are not in the p orbitals. Why? We have the pz orbital of the nitrogen busy doing the double bond. That means that this pair of electrons must be in the sp2 orbital. That means they are accessible, and this type of compound will be basic. And this is the basis of the basicity in these acid heteroatoms. That means we have to check in each of the heteroaromatics where we have the pair of electrons of the nitrogen, for example. Here we have imidazole. This is basic, yes or no? Well, the pair of electrons of this nitrogen are in the p system. But in this atom, they are accessible, they are in the sp2. That means that this compound will be basic in this nitrogen. Moreover, this imidazole is especially basic because, if you remember that I explained, when we protonate, we can grow this resonance form. And what we have is that this compound is especially basic. That means it's basic, and it's more basic than normal because we can stabilize the discharging this nitrogen by resonance forming this other resonance form. For example, in quinolines, the pair of electrons of this nitrogen are in the sp2 will be basic in the case of indoles, this pair of electrons of the nitrogen are part of the p system, will be no basic. Okay? That means checking in which orbital is the pair of electrons of the nitrogen, we can say if one compound will be basic or will not be basic. Thank you very much for your attention and see you soon.